Hi friends, welcome to AKV and this is Vishnu. So this illustration is regarding optimum product mix. Starting towards the illustration, SU Limited produces three products A, B and C. The budgeted production cost and selling price for the next year are assembled. So the company named SU Limited is a manufacturing A, B, C products. So some of the details are given such as direct cost 24, 16 and 12. Direct wages shall be divided into two. Department 1 direct labor hour 4 hour per unit 3, 4 and 3, and then number 1 2 hour per unit, number 2 2 hours per unit 3, 8 and 6. Then we have budgeted production 10,000, 12,000 and 20,000. Maximum possible sales is 12,000, 16,000 and 24,000. Then comes selling price. Selling price is 75, 105 and 60. Then they have given some other details. Variable cost, department 1 recovers at 18%, 100% of direct labor. Department 2 recovers at 50% of direct labor. Fixed overhead 5 lakh per unit. Then we have a direct labor hour in department 1 is short supply and the budgeted volume of the output envisages full utilization of the available direct labor hours. In department 2, the company has committed to engage the workers to the extent of the direct labor hours requirement for budgeted volume of production should change. A change in the production mix shall be desired. The company can engage additional direct labor hour required in department 2 at a normal rate, but any portion of the direct labor hour of department 2 rendered surplus by the reason of the change in the present product mix have to be paid by the company as idle wages in the view of commitment already made. So guys, here is some of the details of SU Limited, and they are manufacturing three products. So they have required us to compute the production mix. So the requirement is, so before going for requirement, I would really like to illustrate this problem. So this over here department 1 is the limited factor, so we need to compute the contribution per hour using department 1, because department 1 is the limiting factor of this illustration. Guys, so the requirement is present a statement showing the budgeted profitability, set optimum production mix and work out the optimum profit after taking into consideration of idle time wages, if any, payable in the department 2. So guys, I'm going towards the solution. First, statement showing computation of profit with budgeted production. In this solution, a table which contains almost 5 columns, particular A, B, C and a total column. Okay. Then we have the selling price. Selling price as 75, 105 and 50. 60. Okay, less cost direct material 24, 16 and 12. Direct labor hour is 4 per unit, therefore 4 per hour, 4 hours per unit, and it should be multiplied with the hourly rate, that is 3, 4 and 3. So we will get the direct labor of department 1 as 12, 16 and 12, and then for department 2 it is 2 hours per unit. When we multiplied such amount with the rate, we will get 6, 16 and 12. Then you need to take variable overhead. Variable overhead is just 15, 24 and 16, and then the total cost or the total variable cost. After taking the total variable cost, you need to deduct the total cost with the sale price. We get contribution. Contribution is 18, 33 and 6. Then contribution per hour. So we need to demonstrate per hour. So contribution per unit divided by the hours used. So over here we have 4 hours. Okay, so you need to divide that hours per unit. So the respective hours is 18 divided by 3, and then 33 divided by 4, and also 6 divided by 3. So I'll get the contribution per hour as 6, 8.25 and 2. Or from here you can rank it as the which you need to select the most contribution per hour or the highest contribution per hour, which is 8.25. So we need to rank the greatest contribution per hour as first rank, which is product B, and then it is 6 as contribution per hour for product A, so it should be ranked as 2. Then last but not the least, the ranking of product C, which is contribution per hour is just 2. Okay, so we have ranked. Now they have asked us to compute the profitability statement. So here we need to take the budgeted quantity first. So budgeted quantities are 10,000, 12,000 and 20,000 from here. Okay, then we need to multiply the budgeted contribution per unit into budgeted production. We will get the total contribution per unit as 1,80,000, 3,96,000 and 1,20,000. And when you take the sum of these contribution, we will get 6,96,000 minus the fixed cost of rupees 5 lakh. Then you will get a profit of 1,96,000. After that, we have a statement showing computation of optimum mix. So here we are computing this statement that will compute the optimum mix of each product. So contribution per hour is 6, 8.25 and 2. Hours required is 3, 4 and 3, which is the hours required for the department 1, because department 1 is the limited factor. Budgeted production is 10,000, 12,000 and 20,000. So when we multiplied it with the hours per unit, we will get the total hours. So the total hours is 30,000 and 40,000 and 60,000 respectively. And when we take the total hours, we will get 1,38,000 hours. So we have 1,38,000 hours. From 1,38,000 hours, we need to divide it among these units so as to get the optimum mix or most profitability statement. Therefore, first you need to take that rank. First rank is product B. So the hours maximum sales units are 12,000, 60,000 and 24,000. Therefore, when we multiply the maximum sales units with the hours per unit, we will get the total hours. Okay, over here we can take that 16,000 into 4, which will give you 64,000. After that we have rank 2. We have 12,000 as demand. Therefore 12,000 multiplied by 3 will get 36,000, and then the remaining hours, which means 64,000 plus 36,000 minus 1,38,000, which comes around 38,000. So such hours should be taken for the computation of for the production of product C. Therefore, the optimum mix will be 12,000, 16,000, and 12,067. Then we need to compute the hiring charge. So the hiring charge will be labor plus variable cost. So labor is 2 per unit plus 2 into 50 percentage, which comes around 3. 2 plus 1 equals 3. Guys, thanks for watching this video. I hope you got complete clarification regarding this illustration. So if you find this video helpful, please subscribe.